Welcome to Walkabout the Galaxy, the erratic astronomy podcast where the science is universal, the opinions are personal, and the hosts are reunited. Didn't I say that last time?
Say that a bunch. You said that a bunch of times.
But it's also true.
We are reunited. We haven't been together since the last time we recorded.
It's kind of not very erratic to say the same thing, though, at the start of each one.
What you mean.
Yeah.
Well,
We are Strange, Charm, and Down, the Astroquarks, also known as Josh Caldwell,
Addie Dove.
and Audrey Martin.
coming to you from the Walkabout studio at the University of Central Florida with three real astroquarks who can't find their top.
Oh, no. Where did it go?
We're topless.
Follow us on Instagram and anywhere else we may happen to show up, but mainly Instagram, where the facts aren't checked and posts can't be reposted, at least not stickily. Is that an acceptable
fair.
amendment to
I like
what
it.
we said last time? But they can be liked, so like away and tell your friends to listen to the best podcast. That's us.
It's us.
The best of all time.
Catch our videos on YouTube. We are at Walkabout the Galaxy. You can email us at wtg@ucf.edu. Our stumper today is in the Flawed series.
Oh, okay. We haven't had one of those.
Yeah. Fly by land, orbit, destroy. And then I was thinking it could also be the Dwarf series or the Old F series, but I thought that's a little bit too risque.
Fold.
Old? That's crazy.
I like flawed.
Where did you get that from? That's a terrible acronym.
How about
Fold.
F old?
Fold. F old. Now you're talking.
F old.
Now I'm super embarrassed that I called it flawed.
I like flawed.
Wait, really? I like
Yeah.
flawed.
But anyway, it never occurred to me that it's fold. It's like I have these
You were
four
listening
letters. I'm
for-
like,
you were
I can
listening
create
to-
all sorts of acronyms with this, and the one that's actually a word never occurred to
never?
me.
That's fine.
Also, like in the sequence of what you would do, you would fly by, then you'd orbit, then you'd land. Destroy.
I mean, it's fine.
Your objects to sort
We could edit that out.
into these four categories are Psyche, the potentially metallic asteroid, which has a mission actually in reality in the real world that we live in or appear to live in.
Also called Psyche.
Irritatingly also called Psyche, on its way to that asteroid. So that's one.
Okay.
Arakoth,
Great.
the gingerbread-shaped contact binary thingy out in the Kuiper Belt that New Horizons flew by. 2018 AG-37, also known as Far Far Out. That's its nickname.
Oh, I remember that.
Far Far Out. It was discovered obviously in 2018, hence its official designation. It is not the thing with the biggest orbit, but when it was discovered, it was the most distant thing at its location when we discovered it.
Yeah.
So it was at about 120 AU, 120 times further from the sun than the Earth. We've seen other things that have orbits that take them out farther than that, but they're currently closer than that.
Oh,
Because their orbits are very
I haven't heard
egg-shaped.
of this thing.
Far Far Out.
Far, far out.
Yeah. Or 2024 YR4.
Why R4?
YR4.
Our newly discovered friend who is apparently not going to
Okay.
wreak death and destruction on us.
Land on Psyche. Flyby. What was the second one? Arakoth.
Arakoth,
I want
the
to.
gingerbread thing.
Well, we've already flown by
we already
Arakoth.
flew by it.
Let's destroy it.
Destroy Arakoth.
Yeah, and look at the spectra. As
This
we
is an
destroy
interesting
it.
point
Sure,
is
yeah.
for the destruction, we should specify whether or not it's like press a button, remote control,
And
and
it's
it blows
just
away and it's
gone?
gone, or you're like there.
And you can.
It's like Star Wars style,
Yeah.
and you blow it up and you get to see what happens.
Yeah.
Let's say it's that, because that's more fun.
That's fun
things.
too.
Okay.
Yeah.
Right, then it's
Okay.
interesting.
Then definitely. Either
Then
way,
it's-
I was going to do ground-based observations of blowing it up, but now I'm doing
No, that would
in-situ
be, you wouldn't
observations
see,
of blowing
I
it up.
don't know if you'll see
little
anything
tiny
ground-based.
things. Little
You'd
tiny
see a
things.
dot.
Yeah, I know.
Then the dot would be
that's
gone.
true. YR4, I think we want to fly by,
Fly by YR4.
which means orbit far, far out.
Okay.
Just because, I don't know.
All right.
Okay. I think destroy YR4, but after it's done a couple of close approaches.
I'm not sure I'm going to allow that,
Why?
just
R4?
because I'm
There's no-
feeling that way.
There's no time constraints on when we're doing these
Yeah.
things.
After one close approach. After after 2028.
Yeah.
Anyway.
Okay. Next time I'm going to
In-
put time constraints in.
Next year, you have to.
Okay. Destroy YR4. land on Arakaw.
Yeah.
Orbit far out, and I guess fly by Psyche.
Yeah.
I think Psyche.
Is Psyche going to orbit Psyche?
Yeah, Psyche's
Psyche's
going to
gonna
orbit.
Psyche.
So you're going to have another flyby of it. That's fine.
Yeah.
I kind of wanted to destroy Psyche.
I was thinking we had to do whatever it is before the Psyche mission gets to Psyche, but I didn't say it when I read it. I'm going to say I like land on Arakoth, the gingerbread thing.
Yeah.
I want to see how soft or smushy,
Gingerbready.
if it tastes like gingerbread, how gingerbready it is. So I want to land there. I think, yes, let's destroy Psyche.
Great.
Because let's see what's inside it.
Yeah.
Right?
Yeah.
Sure.
You
That
know,
makes
this
sense.
metal,
Yeah.
is it really a solid piece of metal or not? What does that leave me? Fly by and orbit. So it would be fun to fly by far out and orbit YR4.
Okay, sure.
That's what I'm going with.
Yeah.
Today we'll talk about so many things, some interesting Oort cloud discoveries, some debatably interesting Mars geochemistry discoveries, a dark matter
We'll
thingy,
debate it.
and much more. But first, this episode of Walkabout the Galaxy is brought to you by N-Body Simulators.
Oh, wow.
For fun and distractions, you can visit the simulations of bodies at the Pirates of the Caribbean and the Haunted Mansion at Disney World, or even the mannequins at your local clothing store. But for the most accurate outcomes, get N-Body Simulators. Tackling the three-body problem and more since the advent of computers, N-Body Simulators let you map the collisions of galaxies and the near collisions of asteroids with Earth. Now, partnering with Walkabout the Galaxy, N-Body Simulators are customizable with a wide array of body sizes, shapes, colors, and even hairstyles. Recreate your world with N-Body Simulators, the perfect body.
Perfect body.
Soul Cycle.
Oh.
Huh. I like that better than the correct answer.
Oh.
The perfect body. Dove lotion. It's not
Yeah,
for
a,
everybody.
I think it is a retired Victoria's Secret.
Oh. That checks out. That
Yeah.
it would be
Okay.
no longer in use.
Yeah. That's right.
So there's a bunch
But
of
also that it would be a slogan for them.
Yeah.
bunch of space news stuff.
Yeah. So many launches.
There were so
About to be so many landings.
right. So what's our update on the moon missions?
Well, so a couple days ago there was so let's I guess we go back. So Blue Ghost 1, which is the Firefly moon mission, is supposed to land on the moon this Sunday. So after we're recording, but before we release
Okay.
the podcast.
So if you're out there listening to this, Google.
Did it land?
Yes. Blue Ghost.
maybe you can splice an answer in. Yes, it landed. Yay.
Yeah. I'm not going to do
Uh-oh.
that. That's
You can't splice that on Sunday night?
I can. I won't.
Okay. Well, we can Instagram
can-
post me
right.
doing those two
Yeah.
things.
Yeah.
Woo! It's supposed to land Sunday or super early on Sunday, so
Okay.
we'll find out how that one goes.
Right.
And then the other one that launched with that, the ice-based one, is still on its way. It's got a really long transit time.
Okay.
Then more recently, last week, the Intuitive Machines 2 mission launched,
Right.
IM2 Athena, and it is on its way. It's only an 8-day transit, so
Okay.
it will be
So
there middle of
fast.
next week.
Zipping
So
there.
about when we release this podcast,
Right.
maybe there's an update for that too.
Maybe.
And then, but along with IM was 3 rideshare.
3.
Yeah, 3
Oh.
other satellites that were on the rideshare.
So there were 4 total.
4 total things.
Oh my God.
Look
that's
at
so
you
many
doing math.
things. I'm
Way
pretty
to
proud of
go,
myself for
Audrey.
that one.
Made so much progress.
Not a big deal. Not a big deal.
So the main one we cared about was Trailblazer.
Yeah, Lunar Trailblazer.
Although you should care about one of the other ones too. But Lunar Trailblazer, which is a spacecraft built by JPL and Lockheed Martin. And that one is maybe not doing so well.
Yeah, it looks like there are some issues with the communication. It looks like soon after the launch, and the launch itself was successful, but
Yeah.
soon afterwards,
Spacecraft separated successfully, all 3 of them.
the communication and power system, something with that wasn't going as expected. So we don't know what's going to happen with that.
I have to make a comment
Please do.
about that
So
because
it's a power system issue. So they've had communications off and on, but it's the spacecraft is power cycling or something like that.
Yeah. This
Is this
it in reality has absolutely nothing to do with what happened to another mission that I'm going to mention in a second here. But Lunar Trailblazer is a simplex mission. It's the program for small innovative missions for planetary exploration.
Why is that of note?
It's of note because I had one of the first two simplex missions, QPACE, with a budget literally 200 times smaller than the budget of Lunar Trailblazer.
Yeah.
Less than $500,000 compared to $90 million.
Yeah.
And guess what the problem was with my
We
200
also-
times cheaper mission?
power and
that
communications?
prevented
Really?
comms.
We think so.
That's our
That's our
best
guess.
interpretation
There's no way
of
it's
the data that
it's
we
the
can.
not the same
exact
issue.
same.
No,
of course
They're very
not.
different.
It's
They're
just
very different buses. and
coincidental.
It's a
spacecraft.
coincidence.
No, it's just a spacecraft thing. It's not a coincidence.
It's a space is
spacecraft
hard thing. It's a space is hard thing.
It's like once you launch, you
Yeah.
have to be able to get stable power, and that is your batteries have to be able to charge up.
Right.
And typically, they're pretty drained when you first
Yeah.
launch. But
and you have to make sure that
supposedly-
you're not spending
spinning or
that
something.
energy quicker than you're replenishing it.
Yeah.
Oh, no.
And Trailblazer supposedly separated well, and its solar arrays deployed. But
Okay.
so they should be getting power, but it's
Yeah.
something with the spacecraft is like resetting, or there's an intermittent power issue.
Still
And you
hope.
need a lot of power to do comms. Is the other
Yeah.
thing. Even with low band comms, you need a lot of power to do comms. And so there's still hope, but they haven't.
So maybe
been-
they'll charge up with their solar panels and
maybe.
Yeah.
And one of the other things that was deployed was called Odin, and Odin.
No,
I
that's
don't get
Thor.
it.
No, that's Thor. Was
It's supposed to be thunder.
is a mission is a spacecraft from Astroforge, which is an asteroid mining startup that was going to try to fly by an asteroid, but they've had difficulties with communications also since deployment.
what are they going to try to? They're going to try to mine it now?
No, they're just going to fly by.
Oh, okay.
The
It's like
company's
a- it's like a
goal
re-
is to do mining. So
like
this is just
a-
like, can we send a thing that's going to fly by an asteroid?
It's a great question.
Metallic.
The
Kinda
answer?
like Psyche.
No.
It might be.
I don't know.
But so they've had maybe some ground station issues, and it might be also in a tumble.
Oh my goodness.
The third one was called Chimera, and that's from Epic Aerospace, and it is healthy and power positive.
Yay.
So that
Whoa.
one's maybe okay.
Okay, so 2 out of the I already
2
lost
out
the
of the
math.
3 aren't doing great.
4.
And
2 out of the
well,
3
2
ride
out of the
shares.
3 ride shares.
Oh,
Sorry.
2 out of the-
yeah.
Yeah.
Okay. That's not
There's
what else?
potentially an integrated flight test 8
Today.
of the SpaceX big rocket
I
in
had
a
read
couple
like
of hours.
March 3rd or something, but it's today.
It's today,
Wow.
February 28th. At least that's what has been most recently announced. in a
Which is
couple of
interesting
hours.
because they still are doing an investigation into Flight Test 7.
in
It's
terms
still-
of what happened with
What's
the
the
other upper
investigation?
stage.
Well, that one,
Oh, that's the one
sort
that
of
was-
made a big,
The upper stage had a problem.
big
Yep.
splash.
I remember that now.
Yeah.
Yeah.
Cool.
Lots of space news.
Wow.
Yeah.
I want to say it's not in space news, but it's in like this is the only part of the pod that it makes sense to mention
Sure.
it. My friend sent me a link earlier today and was like, "Have you seen this?" And it's like Turani makes syrups for like coffee and stuff like that. So a lot of times when you get syrups for like hazelnut syrup or vanilla syrup or whatever,
Yeah.
they have one that's called Galaxy.
Ooh. Does it
and
have
I'm
like
trying to-
like sparkles in it?
It
or
does have
something?
sparkles in it.
Yes.
But it also is, do you remember a long time ago, and it was in 2009, 2 astronomers came across a compound, doing some observations, came across a compound, and there was all these stories about how it would taste like
smelled
raspberries
bright
and smell like
raspberry.
rum.
Yeah.
Oh, yeah.
And so they used fresh raspberry flavor, a rum aroma, and a mineral finish to formulate Galaxy, a one-of-a-kind
Okay.
flavor and must-try in coffee, tea. Anyway, it's pretty funny.
I like Milky Way.
I like
I think
that.
it probably has like sparkles or something.
Okay.
fun.
Yeah,
We'll have to
anyway.
get some.
I don't believe that the last episode we knew yet that the impact chances for 2024 YR4
Wondering that.
had been downwardly adjusted to essentially 0
Yeah.
for
Yep.
the 2032
Which
approach.
we also talked about this on a recent, we'll be talking about this / did talk about this, Time is Weird, on
Time is Weird.
an episode of Are We There Yet?
Yes, you can listen to the Astroquarks on the Are We There Yet podcast, which when you hear this will have been published.
Yes.
Okay.
Are We There Yet? Hosted by Brendan Byrne. So we talked about that. So yeah, it looks like 2024 YR4. Why not R4?
Not a
Let-
problem.
Let's talk about, since we're sort of in the realm of the inner solar system at the moment,
Sure.
and also since I'm interest skeptical about the Mars update.
Oh, okay.
Well,
I was
think
really
it's-
confused by the headlines for this one.
I was
Yeah,
giving
it
Audrey a
was-
hard time about this.
Yeah,
Yes,
it
I
was.
was-
It was everywhere, and I think it is a really good paper. I think the paper
Okay.
itself is really good and it's very thorough. I was saying that earlier. That
Okay.
they basically there's been this kind of confusion about why is Mars red? What is making it red?
Yeah. So the headlines read like scientists finally know why Mars is red.
And I was
we were
like,
"Don't-
really?
Didn't we already know that?
Yeah, that's exactly what I was saying to Audrey,
So the thought was that it was hematite, the mineral hematite,
which is an iron mineral.
an iron oxide.
rust.
Yeah. And like hematite spherules were found with
Yes.
myrrh.
Spherules?
Spherules.
Yeah, little spheres. Yeah.
Yeah.
They're called blueberries. They call them the
Okay.
blueberries. So we have seen
Why
hematite.
isn't it blue?
Yeah.
I don't know.
Come on. Your story isn't holding together here.
Wow.
But
Okay.
In any event,
maybe
it's
this
not
paper
hematite.
was terrible.
The answer is it's not hematite.
Well, those blueberries were hematite, but the thing that makes Mars red is actually
Something that isn't
ferrohydrite.
blue.
Yeah.
Right.
Yeah, ferrohydrite, which is
What?
Isn't that so exciting?
Wow.
Yes! Yeah. So, ferrohydrite is a mineral that we find on Earth, but it isn't super stable on Earth. It's metastable. And it typically goes from ferrohydrite to either hematite or goethite, another mineral, very quickly.
Okay.
But it is stable on Mars.
Because
Okay.
of different atmospheric conditions.
Less
of different
oxygen or
yeah.
something? Is oxygen the culprit in its
don't-
instability?
I don't know.
Typically,
Yeah, I don't know
oxygen
why.
That's the extent of my knowledge of chemistry.
That's
The
I
oxygen
don't.
a
Yeah,
lot of
I'm not
times.
totally sure why it is stable on Mars.
Okay,
and
so
whatever,
So
but-
this is some analysis of all a gajillion data,
Yeah,
spectra,
and,
images, and
Yes, and matching that with new laboratory experiments where they made a whole bunch of
all
different,
these different sorts of minerals.
all of them, mix them together, and they found that the best and only mixture is basalt, which is the rock that you get
What?
from volcanoes,
Lava.
which are all over Mars,
Yes.
mixed with this ferrohydrite material. And ferrohydrite, it forms in relatively cold aqueous conditions.
Makes sense.
So there's this kind of debate about whether Mars used to be very hot and wet or cold, and this is leaning more on the side of cold.
So just if I go to Mars and I scoop up a handful of Mars dirt
Wear a glove.
that's sort of reddish.
Don't eat it.
Okay, was going to be wearing a glove. Never crossed my mind to eat it, but thanks for the advice.
Just in case.
Yeah.
You never know.
I scoop up a handful of that stuff. Am I holding a handful of what did you say?
Ferrohydrite.
Ferrohydrite particles?
Yeah. I mean, it's not 100% ferrohydrite.
Of course.
It's mixed with basalt.
It's mixed with
It's
salt.
mixed with
mostly.
basalt.
Yeah. There's also other minerals.
But I mean, we have these rovers that have been scooping up and
Yeah.
doing all sorts of lab analyses on Mars stuff for
A bunch of that data is
a
in this
long
paper.
time.
yeah.
Great.
Like pretty
Okay.
much all of it.
Awesome.
Yeah.
Yeah.
Cool.
They have like orbital observations,
Yep.
ground-based
Science
rover
takes time.
observations.
Is another word. In other words, is
Yeah.
another thing.
Yeah.
It takes
From-
time to figure things out.
Yeah, data from MER, data from MSL,
Cool.
data from Perseverance, and then also Orbiter,
All
both
right.
NASA and ESA orbiters. But the other kind of like important aspect of this is that it also places a timeline on when
Oh, because
Mars
it's not very
became
stable.
red.
It's
No, it
just
is stable.
meta.
It is stable on
Oh, it
Mars.
is stable on
yeah,
Mars.
so it formed relatively early in the history of Mars, maybe about 4 billion years ago.
Okay.
And since then, Mars has been red. So Mars has been red a lot longer than we previously thought it was.
We thought it was nice blue-green
Sure.
paradise 3 billion years ago,
Maybe not
Perhaps.
green, but
but not red.
not red. Maybe
Yeah.
more brown.
Okay. Well, I'm glad we got that.
Don't you
straightened
find
out.
that so exciting?
Oh, ferrohydrite crystallizes into hematite.
Okay.
yeah.
Yeah. Here on Earth,
Here on Earth.
but
well,
not on Mars.
I mean, it can on Mars.
Yeah, it can.
If
You
you
have to have
had-
the right thermodynamic
If you had the
conditions.
right conditions. Yeah, which it doesn't currently have
No.
and has not had
Not as ubiquitously
for
as
4
previously
billion
thought.
years.
There you go.
basically. Yeah. Okay. Other solar system news. There's an Oort cloud analysis.
I've heard of that.
Oh, so fun random tangent.
Okay.
Fun for me anyway, and maybe fun for you, Addie, not for you, Audrey.
This
so
I'm
sorry.
already just not on board with whatever.
Already
You're familiar
disinterested.
with the concept of the academic family tree,
Yes.
where you're
I love academic family trees.
know.
So
okay. Well,
they're
then
so
maybe you will
fun.
like
Yeah.
this story. So the academic
I
family
was
tree
guessing
is
that was what it was going to be.
Really?
your parent is your academic advisor, right? And then if you had another student and you both got a degree supervised by the same person, then your academic siblings.
Yes.
And there's websites where people have sort of tried to populate this, and so we can all look ourselves up on this website.
Yeah.
And if I look myself up, guess who is one of my ancestors?
Einstein.
Correct.
Oh, that would make a lot more sense.
Jan Oort.
Nice.
Yeah.
That's exciting.
And since Addie was my postdoc, sometimes
Technically,
people count that as
yeah.
part of that whole sort of
I'm
thing.
I'm a purist. It has to be PhD.
It has to be PhD.
Yeah.
Okay.
Oh,
I've had people try
I say
to
it's like
try
a cousin if you're a postdoc.
No,
or like a
cousin. A cousin is if your
That's true,
advisor
yeah,
is
yeah, yeah.
married to someone else.
Oh no, it doesn't
And
have to be
then-
married.
What?
Yeah.
No, it would be
No.
your advisor's like cohort that they were in class. They
Right.
like their advisor.
No, I
Yes.
Yes, that's
That's how
exactly what it
family
would be.
trees work.
Yes.
Okay. Well,
Addie is right.
Because it would be
Audrey.
their academic sibling.
Right.
Would be their academic siblings' academic children are your cousins.
okay, I see how that works. But my
I think
academic
I think
advisor
we've killed this
and
horse.
I consider
for-
them cousins.
as a
Like, it's like
terrible-
like a Latino
That's a
kind of a
little-
cousin where it's like they're just you have cousins, but they're not like
They're not
actually related to
actual
you.
cousins.
Okay. So
for
but I
actual
thought you just said
cousins.
you were a purist though.
You
You're like, I'm a purist. And then you're like, whatever,
you
whoever,
directly
everybody's a
contradict
I
cousin.
can
yourself.
define
Everybody's a
what,
cousin.
I can define my own version of purist.
Which is whatever I happen to think.
Yeah.
I'm whatever
But I
happen
think
You're
to
a
it-
good American.
but I think it's very strongly.
all I'm saying is you're a good American.
Oh my god.
Why are we talking about Jan Oort? Because he
hypothesized
the
Oort
Oort
cloud.
cloud. And
Oh, that's what we're talking
a population of comets that is too distant for us to directly observe. They're up to like 1 light year away from the sun, but they're part of our solar system gravitationally. Left over from the early days of the solar system, blah, blah, blah.
This is one of the things. The Oort cloud is one of the things that always makes Jim mad. I think.
Why?
I'm gonna cite
Okay.
him right now because he's not here. When we're talking about like what's the outer edge of the
Right.
solar system,
Does
we talk
he
about
want it
like
to
the
be in it?
Voyagers.
Does he say, yes, it is?
Yeah,
And therefore
yeah.
the Voyagers are nowhere near the
yeah,
edge of the solar
exactly.
system. It's a defensible
Depends
position.
on how. Or I don't remember which side he falls on, but
Yeah.
it's like, well, how do you make an argument one way
Exactly.
or the other?
Right.
Yeah.
So 4.5 billion years ago, a bunch of icy things got scattered out to very large orbits. And then an interesting thing happens because they're scattered out there primarily by Jupiter. Okay, Jupiter is very close to the sun. So
Relatively.
those orbits still are including Jupiter. So they're very long, skinny orbits. But now those orbits aren't like that. They're basically spherical.
Yeah. Whenever
These
we
things are way out there.
talk about the Oort cloud, we talk about, if we do, which we don't do very often, honestly, when we talk about the solar system, because it's like
It's
so far out, and
out.
there's so little to say sometimes. Anyway, but we talk about it as like this sort of, and when it's graphically depicted, it's like a sphere
Big sphere.
around the solar system.
Right. And there's different sort of regions of the Oort cloud. So one thing that happens after those things are scattered out there is when they're out at those huge distances, nearly a light year away from the sun's gravity is vanishingly small on these objects. So then a very small perturbation becomes important, and that's called the galactic tide, which is the difference in the gravitational acceleration on those comets caused by the Milky Way galaxy itself on the comet when it's far from the sun and when it's close to the sun.
Oh, yeah. It's
Right?
got a
So
differential
the tide have
gravity.
to have a differential, and to have a differential, you need a big distance.
Yeah,
So you
yeah.
need these big orbits, right? So that's why tides don't do anything to the orbit of the Earth, and Earth tides don't do anything to us because our heads and our feet
Right.
are negligibly different
Maybe he does
distances
to like
from the Earth.
Shaq.
Maybe
'Cause
Shaq
he's so
because he's
tall.
taller,
Yeah.
or Wembenyama.
Yeah.
You gotta update
It was-
update your NBA
I know.
references.
I was trying to think of a really recent person, and I was
Yeah.
like, Taco Fall?
Oh,
That's
yeah.
a very local
Yeah.
reference.
So
Even Audrey doesn't know that one.
those tides lifted the
CFS.
perihelia of a
Oh.
bunch of these Oort cloud orbits so that they no longer were coming in close to Jupiter. They're just always way out there. Then, because tides are complicated,
They're so complicated.
those tides
How do they
and
work?
also passing stars occasionally cause some of those things to then
Little
fall back
perturbations.
in
Yeah.
to the inner solar
It could
system.
kick things out. It could cause them to fall back in.
Right. It
Yeah.
gives them enough of a blip that it's a huge relative change in their energy. Sometimes they just fall back in, and we see those as long period comets, and that's how Oort figured out these things were out there. So now the new story is a team has done some numerical simulations of some n-body using an n-body simulator.
As one does.
Yeah. Some simulations of the inner portion of the Oort cloud and found that over time it creates a sort of a S-shaped spiral structure in the inner Oort cloud,
And it's when you're looking from the perspective of like the galactic plane.
way outside.
Yes. Yeah.
Yeah, it's perpendicular to the galactic plane
Yeah.
because our solar system is sort of perpendicular to the
I
galactic
didn't
plane.
really. I don't ever think about that.
Yeah, we always like to think everything is always in the same disk, but our solar system is tilted.
Why?
Because
We don't have to get into
let's
it.
not get into that
That's
right now.
another time.
This thing is tilted
Cliffhanger.
by something like 30 degrees to the plane of the planets, which
Oh, interesting.
is surprising.
That's a
strange
lot.
number.
But I think that that's a combination of it's governed by the sun and its original orbits, which were probably mostly in that plane, and then the galactic tide, which is mostly orthogonal to it, and that's combination. You end up with something at a wonky angle. So
That's
yeah.
interesting.
So
And it's
another
interesting to
spiral.
me that it's the inner Oort cloud that's affected by this, but the outer Oort cloud, they say, is still probably roughly spherical.
Right.
It's further
Right.
out at like 10, and you'd think that would be more easily
Yeah,
perturbed and would
why-
be less likely to be spherical.
Right.
But is it perturbed such that it's sort of,
All randomized.
yeah, that's
yeah.
the word.
Yeah, the combination of the tides acting on those distant things, it's a stronger effect on them. And passing stars also have stirred those up
But
much
it's,
more.
It's much more isotropic, where it's just
Right.
sort of like equally
Right.
distributing it even more randomly.
Right. So so
That's a little surprising.
the inner Oort cloud, by the way, is still way the heck out there.
It's like 1,000 to 10,000 AU.
Right. Up to 10,000 times further from the sun than the
Many.
Earth. Yeah.
Several.
Yeah. So
Cool.
really far out there. Yeah. Shall we hear our trivia for today?
Yeah.
I don't know.
I've had occasion recently to tell people who don't know anything about me or my line of work what I do. And you've probably had this kinds of conversations as well. And so
I never tell anyone what I do.
there's
Say top secret.
a tangent here about like what are the actual
what words
appropriate
do you use?
terms to use,
Yeah, this is
right?
very complicated
Very
conversation.
complicated. Generally, if I'm with a population of people that's far outside my realm, I'll say astrophysicist.
Oh, because you want to seem smarmy.
It has a certain smarmy air, but also my PhD is in astrophysics.
Mine's in astrophysical and planetary science.
My whole thing is astrophysical, planetary, and atmospheric.
Oh,
but
yeah, you were back when it was
before,
AS.
yeah. But all my courses were the astrophysics courses.
Yeah.
I didn't take the planetary
Well, that's
sequence at all.
why.
Well, that's confusing. All of my graduate courses were geology, but I'm pretty sure my PhD says astronomy. So what does that make
funny.
me?
Yeah,
That's
confusing.
up to you. Nobody
So,
is going to ask for your PhD when they're
if you
having
tell
this
somebody
conversation.
you're an astrophysicist, they're like, "Is that a real thing?"
I've
I've never
gotten
met
that
somebody-
before.
Well, because you've never told somebody you're an astrophysicist.
That's true. I've told people that I'm not an astrophysicist.
and they're like, "That tracks."
But I play one on TV.
yeah.
I pretend to be one on a podcast. You
Yeah,
should check
exactly.
it out.
Yeah.
So
this
the
is all
question
a ruse.
how rare is it to be an astrophysicist / astronomer? Okay.
Is that, are we defining ourselves as those things for this? Does it matter?
It doesn't matter how we
Okay.
define ourselves for this. So specifically, your question is, how many new astronomy PhDs are produced each year?
Oh, in the U.S.
I
Or
have a
globally?
U.S. number
Okay.
based on my somewhat lazy research. I believe the U.S. number is about half of the global number.
Oh, really?
Wow, I expected it to be higher.
Maybe it's 60%.
Oh, I was thinking it would be lower.
Oh,
Yeah.
I guess I wasn't thinking about like
You know,
China.
Yeah.
we're going to use astronomical precision here, which
Sure.
is sort of
Mhm.
order
Yeah,
of
yeah, yeah.
magnitude.
Got it.
That works.
That's
It's
fine.
not 10 times higher and it's not 10 times lower.
Yeah.
Cool.
Okay. So that's your question that we'll come back to. Yeah.
Cool.
Yeah.
Oh.
Are there follow-ups then?
Not really.
Oh, wow.
Yeah. Pretty basic.
Okay.
The follow-up, we can talk about what other things we maybe should call ourselves and why we don't because of all the questions that it would
That's true.
elicit. Yeah. So another story we had was about a dwarf galaxy and a dark matter story. Which would you like to hear about next?
Well, I don't know. The dwarf galaxy one sounds like why bother to me.
So then I'm going to tell you that since you told me about Ferris Hydrite or whatever it was.
Fair is fair.
Very briefly, there's been a discovery of a dwarf galaxy near the galaxy Andromeda.
Yeah.
And it looks, speaking of galactic tides, stretched out, indicating that it may have had its own tidal interaction with the Andromeda galaxy. Andromeda galaxy is our biggest near neighbor galaxy, our nearest big neighbor.
And we can
galaxy.
see it very easily with the naked eye.
Yeah. Well, if you're in a dark sky.
Yeah.
Yeah. And if it were really, really, really dark, it's like bigger than the moon in
Yeah.
the sky. It's huge.
Large.
It's
I
very.
knew that.
It's
structure.
a big old galaxy, and it's
Even
not
though
that far away.
I'm not an astrophysicist.
It's just faint.
It's our neighbor.
Yeah. So like we have the small and large Magellanic clouds.
We do.
Andromeda has some dwarf galaxy neighbors.
Checks
This is
out.
a new one.
Okay.
How many
Pegasus
other?
7.
Pegasus 7.
So
Are
is
there
it the
Pegasi
seventh?
1 through 6?
Yes. Oddly, Pegasus 6 isn't called Pegasus 6. It's called Pegasus W. And the paper says, we call this Pegasus 7 because Pegasus W was the sixth one or something. I'm like, okay, now you're just making things up. I don't want to call myself an astrophysicist anymore.
Yeah, right.
So that's out there, and it's, a way to sort of explore galactic collisions. And we have sort of a new example of like galactic interactions to look at with
And
that.
dwarf galaxies are interesting because we think that they're typically very, very old. So, like, they tell us about sort of the history. Yeah, as we were saying.
Looking
the
back
history,
in time.
Looking really back in time. And this one's estimated to be around 10 billion years old.
That's
Oh,
old.
Very old. But it's very, very, very faint.
Yeah.
So that's why it's hard to find.
Yes, and has only been found just recently. Yeah, because it's out there as this dim, fuzzy patch. Then you have to determine like what actually am I looking at. The other sort of dim, hard to see thing.
Insert.
There are many of these things in astronomy. That there's an interesting update about dark matter.
Dark matter.
all right. Now we're getting
Yeah,
cooking.
we're going to do all the interesting dark
we know what
matter
it's
stuff
made of
without
yet?
Jim. We do not.
I don't care then.
So there's a way you can sort of measure the mass of things by looking at the deflection of light because of general relativity. So within our galaxy, pulsars, which are these very precise clocks, basically, they're like flashing lights in some sense. They're rotating very quickly, and you see a pulse of electromagnetic radiation that's periodic with the spin of the thing. So they're pretty regular, dependable timers. And if the more matter there is, that affects the apparent timing. So if you have a whole bunch of these, sort of a network across the galaxy, they can tell you something about the distribution of matter within the galaxy by looking at the change in those
That like sort of moves them around.
periods of those pulsars.
Yeah.
And but it's complicated. I know that sounded super simple the way
Yeah.
I described it. It's
Yeah.
not as simple as I described it because they slow down for other reasons on their own. Like there's like magnetic braking that happens with stars. Anyway, the new story is that they figured out a way to control for that and increase the number of pulsars that they can use to sort of measure the mass in the disk of the galaxy,
Ooh.
which then places a more precise limit on the amount of dark matter in like our neighborhood, right, in the region of the galaxy where we're living. And so it lowered that limit. And basically what they're doing is they're measuring or they're placing a limit on the acceleration of this thing. And this is really why I wanted to talk about this story, because the acceleration is that they're down to is 10 centimeters per second per decade.
What?
In other words, the change in the speed is 10 centimeters per second each 10 years.
One of the articles we were reading about for this was the University of Alabama Huntsville press release, which is like the lead authors are from UAH. And like there were several references to like babies in this
Babies
one.
and
apparently
snails.
10 centimeters per second is the speed of a crawling baby.
I thought it was a snail for some reason.
Well, they're very similar, babies and snails.
Babies and snails. 10 centimeters per second probably is actually, I don't
That's
know,
pretty
that's
fast
maybe
for a
fast
snail.
for a snail.
Yeah,
Right.
I've watched some
10
snails.
centimeters is 4 inches. So, yeah. So that means that they're measuring an acceleration that's so small that it takes 10 years for the speed to change by 10 centimeters per second. And what's the answer about dark matter? The new limit is just that if you took a blob of space the size of the Earth, there would be less than 1 kilogram of dark matter in that blob.
That seems
Near us here.
Yeah.
Hereabouts.
So it's relatively
disk.
not dense here.
Here.
In
I thought it
in
was-
in the boondocks of the Milky Way.
So that's a lot less than what we previously thought.
Well,
Well-
there's lots of volume out there.
Yeah, and there's more dark matter in other places.
Right. It's
Oh,
mostly in the core and I think spherically distributed around the core of the Milky Way. So not
okay.
out here in the sort of in
So
the
it
boondocks.
trails off
Yeah.
enough.
But also there's lots and lots and lots of volume of space. I mean,
Well, yeah, that's true. That's fair.
the amount of regular matter in an average Earth-sized ball out here is a very, very, very small number because
that's true.
it's mostly empty, right?
Yeah.
Some of the press releases were a little, not the press release, but some of the stories about this have been a little bit misleading. It's like there's less than 2 kilograms of dark matter in the Earth, which is a little bit of an unfair comparison because dark matter doesn't care about the Earth at all. It has no reason to be in
Rude.
where regular matter is, right?
We're
Yeah.
clearly the
But
most
I
important.
care about dark matter.
Yeah,
Yeah, we care about dark matter. Why doesn't it care about us?
Yeah.
I
This
know.
isn't a very reciprocal relationship.
It is not a
Wow.
reciprocal relationship. Okay, so how many
Rude.
astronomer / astrophysicist types are there out there in the world? Let's approach it by having you tell me how many astronomy / astrophysics PhDs are produced in the United States each year.
50.
Okay.
200.
Oh, 2 good guesses.
Thanks.
And Addie is closest, about
higher than that.
160.
Oh, okay.
Yeah.
Oh, okay.
So about 160 a year from a few years ago is the most recent data that we've got on that.
That's so few.
Most of those people do end up going into a career in astronomy or astrophysics, at least
Oh,
initially.
really?
Yes.
Oh,
Like, by that
that's
you mean
good.
go into
90%.
postdocs or something?
Postdocs or related fields, even in, yeah. So go into that kind of field. I don't know, 10 years or 20 years down the line, I don't know.
Yeah.
So if they get their degree at 30 and they work to 70, 40 years, career, 40 times 160. And if we say that worldwide there's maybe twice that number, then it's 40 times 300, that's 12,000.
Wow, so
There's
many.
definitely
whole
less
world.
than that because I feel like a lot of people, not a lot of people, but I feel like there are people that trickle out.
There are people that trickle out, but also there are
Totally.
professional astronomers who do not have a PhD in astronomy or astrophysics.
Yeah, that's true.
One of my role models when I was a graduate student and in my career is Professor Joe Burns at Cornell. And guess what his PhD was in? You'll never guess.
Agriculture.
Naval architecture.
Oh,
Yeah,
cool.
and he is a brilliant, planetary
That's fun.
dynamicist.
Yeah.
Right. So that number of 12,000 sort of tracks with a couple of other metrics we can use. The membership of the International Astronomical Union is about 12,000.
Okay. I was
Oh.
gonna say
Member-
AAS.
Is
Okay.
about 7,000.
Okay.
Right? So I'm not a member of either of those two.
I occasionally am a member of
Institutions.
AAS because of DPS.
Yeah,
I'm an
I
affiliate
am-
member of AAS.
Yeah, that's true.
Yeah.
Oh, if I'm a member of DPS, does that mean I'm a member of
You're an
AAS?
affiliate member.
Oh.
I don't-
Okay.
That's probably counted in that 7,000.
Yeah.
Yeah. But that sort of gets back to why do we call ourselves astrophysicists? If we say planetary scientists, people are really confused.
Yeah, they assume it's something with plants.
Yeah. Guess what?
That's-
I didn't tell you guys what we're
You
saying
didn't
on the way
really
out.
pass the paper
Yeah.
or something.
Well, While it may have felt like a collision of galaxies, it was just another episode of Walkabout the Galaxy.
Be sure to follow us on Instagram and YouTube. You can contact us at wtg@ucf.edu.
Our theme music was composed by Richard Jerusik. Production assistance is provided by Logan Basinger.
Thanks to our listeners in Manitoba and around the world. I'm Josh Caldwell.
I'm Audrey Martin.
And I'm Addie Dove. We're the Astrocorks signing off until the next episode of Walkabout the Galaxy.
It worked better
We
that
did
time.
it. That was
even.
so good.